Okay, hello everyone. Today's video we're going to be discussing forms of linear equations. This slide might look familiar to you in that we talked about it when we were covering linear models, but I want to use this slide to discuss a different form of linear equation. In this section we'll learn three of them. We're starting with something called slope-intercept form. If it looks very familiar, it should, in that y is still the dependent variable. M is still slope, or the rate of change. X is the independent variable. But B, we're going to call B now the y-intercept. So we had previously called it an initial value. And that made sense for a linear model, in that it was the initial value of the dependent variable, or where the independent variable was equal to 0. But algebraically and geometrically, it's better to refer to this as the y-intercept. You'll see why when we graph it in just one second, why I refer to it as the y-intercept. But B, moving forward, we're going to discuss as the y-intercept. Okay. So, the definition of the y-intercept. The y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis, which is when the x-coordinate is equal to 0. So we have a line, any linear line. I'm just going to draw a quick axes here, x and y. Here's a linear line. I'll identify in blue here the point at which the line crosses the y-axis. Let's say that this is 5. So this is the coordinate point where x is 0. When the x-coordinate is 0, the point 0, 5. Okay, so we'll look at this more in a graph in a little bit. That's the y-intercept, geometrically. It's literally the y value, okay, of the coordinate point where a linear line crosses the y-axis. Okay, identifying slope and the y-intercept. So, these next few, I'm going to give you a couple of equations in slope-intercept form, and I want you to identify the slope and the y-intercept. Really easy stuff. And that is simply, because it's in the form of y equals mx plus b, we're identifying m and b. In this case, m is negative 2. It's the coefficient to x. B is positive 9. So, when I ask you to identify the slope and the y-intercept of the line, described by the following equation in slope-intercept form. If it's already in slope-intercept form, it's really easy to do. Slope is negative 2, y-intercept is 9. Next one, same thing. Here, m is equal to negative 3, and b is negative 9. Now note the negative value of b. If it's negative 3x, subtract 9. The y-intercept is negative 9. It's not positive 9. It's just not the numerical value of whatever number follows in the constant term, or follows linear, the constant term that follows the linear term here. No, this negative, or subtraction sign in this case, is along for the ride, and we describe the y-intercept as being negative. So if you graph this, it will fall as a negative y value, and you'll graph it as a negative 9. So that's important to keep in mind. Okay? And you try one as well too. I want you to identify the slope and the y-intercept. Okay, now we're writing an equation in slope-intercept form given a slope and the y-intercept. So kind of the reverse. Very easy to do. We're given the slope as being 3, which I underline in blue. We're given the y-intercept as being 8, underlined in red. So once we identify, that's really easy to do. In that we're still working with slope-intercept form. Y equals mx plus b. In this case, because m is 3, y is equal to 3x plus 8. Okay. Let's see one more example here. Now just write this in. I'm sure everybody is totally following this. Is 100% on board. This is really easy so far. The slope is 6. The y-intercept is negative 5. Given that that's the case, y is equal to 6x minus 5. Okay? Now you try one. Slope of 7, y-intercept of 8/3. Okay, now what I want you to do is create a table of values, or we're looking at creating a table of values for the equation y is equal to negative 2x plus 9. Now, all we're doing here is plugging in for these values of x, the input, and then generating the respective output y. So I'll work with this first one here, and we'll title this A. So the work for A down here, if I'm substituting in for x is equal to negative 2, it's just simply negative 2 times negative 2 plus 9. or in this case, negative 2 times negative 2 is 4, plus 9 is 13. So what's the coordinate point that I'm generating here? I'm already given the x value here, that it's negative 2. When I'm solving for y, that's its respective y value. So it's important to consider this as a coordinate point, in that I've plugged in for x, I'm generating a y, and I'm getting the coordinate point negative 2, 13. So if I want to graph this, negative 2, 13, okay, let's pretend like this is increasing up to 11, 12, 13, right? So this is negative 2, 13, something like that up there. So now I'm plotting this point, 13. Okay, so I'm not going to go through all of these and evaluate them at all their specific values. You should be able to do this work in your head. All you're doing is multiplying negative 2 times these x values and adding 9. Negative 2 times 0 is 0, so that y value is 9. Negative 2 times 2 is negative 4 plus 9 is 5. 4 times negative 2 is negative 8 plus 9 is 1. And 5 times negative 2 is negative 10 plus 9 is negative 1. So I'm plotting all these points. I'm plotting the point 0, 9. I'm plotting the point 2, 5. I'm plotting the point 4, 1. Says 4, 1? Yeah, 4, 1. Can't read my own handwriting here. And then 5, negative. Okay. Okay, note my point negative 2, 13 is slightly off, but let's pretend like this is the linear line and it's nice and straight that I have to follow. Right, this linear line here. Note the value of the y-intercept. It's where x is equal to 0. So in this case, we say the y-intercept is equal to 9. And that makes sense because look, it's the point at which this line intersects the y-axis. And given the slope-intercept formula that we've identified, we have the value of positive 9 as b. So we know that that's true, and that's the case. All right, so this should be something you're familiar with, plotting points, filling out table of values, maybe just even a refresher for most. So I want you to try for the following table, plot this, and then graph the line. So y is equal to 3x minus 4. Okay, writing an equation in slope-intercept form given a point and a slope. This is sort of the most challenging work so far that we'll deal with. So I'm given a point. So when I say given a point and a slope, that means I'll underline in blue. I'm given a point and I'm given a slope. So I'm writing the equation in slope-intercept form of a line that passes through 1, 4 and has a slope of negative 3. All right, so let's deal with this step by step. First, we find the y-intercept by substituting the coordinates of the point and the slope in the equation. So what's the equation? We should all be familiar with this. At this point, y is equal to mx plus b. Now, if I have this coordinate point, note that this is xy. This is just, it's not the only coordinate point that's present on this line, but it's a given coordinate point. So I can say that a pair of x and y coordinates that's present on this line is 1, 4. So for values of x and y equals mx plus b, I can therefore substitute 1 and 4 for x and y respectively. The slope being negative 3. So m is negative 3. So note that x is 1, y is 4, m is negative 3. I've now taken care of three of the 4 unknowns in the 4 unknowns in this formula, y, n, x, and b. So when I substitute this, I get y is 4. So substitute negative 3 for m. I'll fill this out over here first. 1 for x and 4 for y. And then I'll come back over here. I said m was negative 3. X is 1. And I'm left with b. Now in this equation, algebraic equation, which I'll box out in green, now we have an algebraic equation of just one variable, meaning we can easily solve for b. So how would I do that? Negative 3 times 1 is just simply negative 3. So I'll write that out just to be clear. How do I solve for b here? Adding 3 to both sides. Add 3, add 3. B is equal to 7. Step 2, substitute the slope and y-intercept into the slope-intercept form. So now that I know what my b is and I know what the slope is, this is the exact same work as we were doing a couple of slides ago. in that, and I'll circle this in red, b is 7, which we solved for, but we're given 3. This value up here. So in the form y equals mx plus b, we know that the slope is -3, and we solve for 7. So my final answer in slope-intercept form is y is equal to -3x plus 7. So there's a little bit of algebraic figuring in that you need to substitute the x and y coordinate point that you're given and the slope into y equals mx plus b, solve for the y-intercept, and then substitute the slope and y-intercept into the slope-intercept form to generate my final form of the equation. Okay, I'll do this one more time just to be clear, and I'll kind of speed through this, and I'll ask you to do a your return problem. So I'm given the coordinate point 3, 2, and a slope of -1. Once again, in y equals mx plus b, we have x, y, and m. So this is 2 is equal to -1 is the slope times 3 plus b. Note that I've substituted for x, it's underlined red. I've substituted in for x, y, and m. And then I'm just simply solving for b. So -1 times 3 is -3 plus b, add 3 to both sides. b is 5. Step 2, substitute the slope and y-intercept back into slope-intercept form. I'll circle these or box these out in green. We're given the slope of -1. We've solved for the y-intercept of 5. So we say y is equal to -x plus 5. Well, wait a minute. What happened to the -1? Silly students. -x implies a coefficient of -1. Now, do I ever want to see you write the -1 before x? No, I do not. So let me erase that. Once again, -x implies a coefficient of -1. So if I ask you what the slope is for y is equal to -x plus 5, that slope is -1. Okay, so I want you to try your term problem along the same vein, and we are done. Okay, see you guys back in class on Monday. Hope everybody did well on their quiz. Andor is watching this and studying hard for their quiz on Thursday. Under 13 minutes. Yeah.